Hello everyone. So today we are talking about linked list and primarily some of, like many of us not having a very good grip on basics. So one of my friend asked, so I am doing this video. So let's learn what is linked list in very basic level. So let's not focus on like a big O notation or too much of complex theories. Our primary focus is what is linked list, and we need to understand it and like fully digest. Like we should be able to understand. Okay, let's get started. So now, the current topic is we will talk only on singly linked list, and there are different types of linked list: doubly linked list, singly linked list, doubly linked list, circular linked list. So, three types of linked list will be there. In circular also, circular singly linked list, circular doubly linked list also possible. Okay. Huh. So our focus is under the data structures. We will learn today on singly linked list. How do we build that? And we will see the sample code and we will discuss. But before sample code, our primary focus is on understanding the linked list and where we will use, what is the real-time use case, where this linked list will be used. That kind of questions will be there, right? Those things also we will talk. Let us see what's there. So these are the real-time use cases I tried to capture from the internet, and I did a little research. So the use cases are to create other data structures. Like if you want to create a stack, queue, or something like that, linked list is a better option. And so the other one is creating a dynamic memory allocation. You want to create a memory allocation dynamically, so this is the one of the option I understood from the internet. And so if you want to do implement undo functionality, redo functionality, then linked list is one of the best way to maintain the states of system, and moving forward and backward, and system or application or any entity for that matter. You want to undo, redo, undo for a certain number of times, redo for certain number of times. If you want to implement such features, linked list is best option. Okay. And examples here, you can see image viewer can be considered as doubly linked list. Moving forward backward is possible. Music players will have a set of movies or a set of audio music songs will be keep on playing. So what's happening there, one song is completed, then it is going to the next linked node and playing the next song. So that can be implemented through linked list, and in the linked list we are traversing the songs. That's it. And video play can be considered playlist. Basically in YouTube you will have a playlist, and continuously it will play first video, second video, third video. So all those videos are in a list, virtual list, but one video will be saved in different location, other video, second video is in different location, third video is in different location. All videos you can virtually group into one single list. That's what you do in a playlist, right? In YouTube playlist. So that can be treated as a single linked list, or like a doubly linked list for that matter. It's a linked list. Okay. So there is a multiple examples in the market. So these are the simple examples. Let's go for next. Okay, once again. So this is the notes I try to capture from net. Okay, a linked list is a way to store collection of items like numbers or names or even objects or anything. So same type of object, or you want to store different type of objects, it's up to you. But linked list, using linked list, you can store a collection of homogeneous objects or heterogeneous objects. That's what my point here is. Unlike arrays, data is not stored in one block. So in arrays, if you consider entire data, array is not a single object. Array will have few objects, and all the objects, first object will consume a specific memory, and continue to that, next object will consume the memory, continue to that, next object will consume the memory. That's how the regular lists will be in most of the programming language. Okay, but okay, in our regular lists, or many programming languages call them as arrays. Okay, and data is not stored in one specific block. Linked list will not have entire data in one specific block. Like videos, one video is stored in one memory and the another video is stored in another memory, but still you can create a playlist. Playlist we are considering here as a linked list. Okay, and each item is stored in a separate node. So first video is stored in a node, and what is the next video for the current video is so the next memory will hold the address of next object, next node, basically next so. And what will be, how that linked list constructor will have, or how the linked list structure is, let's talk now. So every linked list is made up of multiple nodes. Okay, every node will have two parts. One part is the data part, the other part is a next part. The next part will hold address of the next node. Okay, data part will hold any object. Okay, so any object, that can be any, it can be integer, or it can be a class, or it can be any structure or anything. So I'm just trying to generalize. I'm not going with a specific to Python. Okay, so the first node is in the entire linked list, the first node always called as head node. Okay, and the last node always pointing to none. So when the linked list is pointing to none, which means we will consider that as a end of that linked list, and this is the last node. So this is the only way you will be able to find out what is the last node. Means the nodes next is pointing to none. Okay, meaning it is the end. Okay, so you can also add, delete, or move through the list by following the links, next pointers. Okay, it is helpful when you don't know total size in advance, or need to insert or delete often, then it is helpful. Which means you want to do some collection, you want to build a data structure for a collection of objects, then you don't know how much memory it will occupy in advance, then you can go for a linked list. And current node, if the data is ready and you want to put into current node and add into the existing list, where you will add at the end of the list. If the list is fresh and empty, then where you will add, obviously at the head is itself is empty, then instead of head we will add that node. So whatever is value you are having, that value will be added to head. So let us see here in the screen. Okay, so linked list will follow, usually these are the general operations. So in, if you consider creating a simple list, writing simple Python code for a linked list, we will do this operation in this particular video. And creating linked list, like when no elements in linked list, how do you create? So that particular thing is covered. And when there is elements in the list, and how do you insert that elements? So adding the elements at the end, how do you do that? And traversing the list, display, search operations, reverse operations, sort elements, all these things I will not do in one video, so I will do it in next videos. But we will see the basic code here. Okay, reversing and sorting I will not do in this particular video. So at least we will see display and search. If possible, we will do those two, or else like we will do another video. Okay, deleting elements, this also I will not do, but let us see. If possible, we will see deleting at last. So last node deleting, last node deleting, like that, all the nodes deletion of the linked list. Or at a given point you want to delete a node, so how to do that, that also we will see. But in multiple videos I will cover all of them, not in a single video. Okay, let's go to the next. So here is a way we can see what is that linked list. Okay, here, so the 10 is a data, and a dot is a next pointer. 10, and in a square bracket I have put 10 pipe symbol dot. Dot is, see, you imagine dot is a memory pointer which points to this 20 object. So in each block you see here, first block is having data as a 10, and pipe symbol is there, right? That is the second, first partition is data, second partition is pointed to the next node. Okay, so that I try to represent with a black dot. And go to the next node, and next node is having again a 20 as a data, and the second partition is pointing to the next node again. When I pick that next node address and go to the next node, so the data is holding 30, and second partition is having next node. What is next node pointing to? Next node pointing to none, which means this third node is the last node in this entire linked list. Okay, so this is how you will see the linked list. Let's take, so a lot of, so you can see in the right top corner, so this is a H is a head, T is a tail, or last node. Okay, this is the middle, but this white color thing is a pointer to the next node, and this H, the blue color one, is a data. So every place you may have a data, or you may not have a data, it's up to you how do you want. But if you want to keep a node, one data section, one pointer section, like that usually will be there. Let's go to the next. So here is a very basic level of Python code. I try to bring it here. Class node, and as we said, data block and next block. Next is a pointer to the same node. So in the linked list, always will have data section and pointer section. So that is why here data section, whatever is variable is being passed is stored into data section. Next is what? Next is currently it is none, but this particular node will be utilized in a linked list class and try to construct. This is a structure. Okay, this is how any basic linked list will have. If you have a doubly linked list, couple of things will be added more, that will be previous also will be there, but let's not get into that particular complexity. We are focusing only singly linked list. Okay, singly linked list always will have data and next it will be like this. First thing is data and next thing is pointer. Okay, let's go next. This is the code. Here linked list is all the operations we will do using this particular class inside the linked list. So when you are initializing this linked list, so for the first time nothing is there. So that is why when you are initializing this class object, that will have head as a none. Okay, this linked list also will maintain always a head pointer. Okay, so we will not change that head pointer position. We should not, in fact. Okay, only when we are adding a, for the first time, if we are adding any values, then only we will change that head node, or when we are deleting all the elements and the last time you will delete the head node. Okay, or when you are deleting first element in the linked list, then you obviously need to change that head node. So but you will deal you will change the head node rarely, until unless you delete something in the starting. Okay, so that is why it is obviously maintained in the init class, init function of the class. So usually if you consider any other programming language, that will be part of constructor. Okay, so in Python, so we only use that initialization method which is called as init under that, and so the we don't focus on the constructor part. So let's take this part. Okay, self dot head is equal to none. Okay, and the second thing is adding a node. When this particular class is instantiated, self dot head will be obviously none, and linked list dot add node, if you call, what happens, you'll need to pass some value. That value will be stored inside a node object, node of a value, which is, you see here, this is the part, node of data. So that data can be a 10, 100 or number, or it can be an object or anything for that matter. Usually we will take an object. Okay, so node of value will be stored as a new node, and this new node we will see first time. If the self dot head is pointing to none, then self dot head is equal to this whatever we have constructed, that new node will be added, and we are exiting this particular add node function. Okay, and if that is not none, what we will do, we will traverse from head to last node where the current node dot next is pointing to none. Till that place you need to traverse. So when you want to add here, so here let us say this is the head, right? Data is done, and next pointer is not none. Okay, because next pointer is pointing to this address, so it is not pointing to none. So we need to go to the next. So this is a current. Now this whole object is a current object, and its data section some value is there, but our focus is on memory section or pointer section. So where it is pointing to, again it is pointing to next section, so which is not none. So here also we will see, here it is obviously pointing to none. So we will take this particular object, and this particular 30 dot next is none. 30 dot next is equal to whatever created node here, right, new node, that will be assigned. See here, current is equal to self dot head. You took the current, and you are moving this current to next like that. So how do you move? While current dot next, so simply if you put column, which means current dot next is not none. If current dot next is not none, So you are changing that current is equal to current dot next. Again see, if current dot next is not none, again current is equal to current dot next. When you go to the last third node, current dot next is none. So current is already previously placed, current is holding the last node, and current dot next is equal to new node, which means new node dot next is already none, right? Current dot next is equal to new node. You have inserted that element or a new node at the end. That is the way you can add the new node. And search, so you are passing the 10 as an element, and current is equal to self dot head. You take again, always you will need to create a temporary variable like this current. Under this current you will take the head, and you will try to traverse this current node to next like that. So current, while current means while current means, if current is none, current object itself become none, so you will exit that traversing. If it is not none, so you will keep on traversing. Okay, so while current is none, not none, you will go inside. If current dot data is equal to target, which means you found that value, so then return true and I found it. Current dot, if it is not found, it will go to this third line, next line, which is like a 22 line. So current is equal to current dot next, and again you see what is current in the next element is none, means it will exit and not found. If next element is not none, so again current is equal to current next, current is equal to current next. If it is current dot data is equal to target, found means return true. If it is not found means return false. Till the last it went, but it is not found the target equal, then it is not found. So value not found, so you are returning false. Okay, the next thing is printing the all the list. So like here also we traversed, here also we traversed. While traversing, current dot data, if you print, that's it. You see here, while current, print current dot data and arrow, and current is equal to current dot next. Again current is none or not, you will see, and like that you will go, keep on going. So maybe in the next screen I added a main function. How do you write the main function for this? So my list is equal to linked list. I created a class object for this. When I create a freshly first time in this particular line 5, this my list will hold null linked list, which means it doesn't have any elements. Then this particular object dot add node, when I call, this particular add node was called, and 10 is being passed, that will be stored into the data node. Here you see the value is where you are saving, you are actually passing to the node class. What are you doing? That node class second argument is considered as data. In this place the 10 will come, and that will go into data part. Next part is obviously none. So my list dot add node 10, when you say my list dot head will be added as a one, will be holding one node, and head dot next will be none. Okay, my list dot add node is 20, means it will first, it will go to the head, and it will check is that is the head is empty or not. It is not empty, obviously. First we added one element, right? So head dot next, it will check it is empty. So head dot next, it will create whatever is the current node is created, new node, that new node will be added in the head dot next, at the head dot next, and new node dot next is obviously empty. So like that these three elements will be added, 10, 20, 30. So now print linked list. So how do you print my list dot print list? We have wrote here the code, right? So it is traversing one next, and so current is equal to current dot next is the primary trick here while current. So each time I am printing, print current dot data. Okay, so yeah, that's it. uh, yeah, so mylist dot search 3020. So whether it is found or not, it will check. So we discussed already, search we discussed, and printing the data we discussed, and adding the node uh, at the end only we have discussed, not in the middle or starting place we have not discussed. But yeah, I hope we had clear understanding on linked list now. So let us see if there is any help needed. I'll go through again any specific thing you like me to explain. I'll go through that. So please put that in comment section. Thank you. Bye.